Welcome all to the presentation of our project, which is Digital Inspector. Next slide, please. I'm Lewis Watts, Head of Engineering at United Living, and I will be providing the introduction and general overview of the project. One of our partners, Triton Electronics, will be providing a bit more sort of deeper insight into the specific work packages that we undertook during this discovery phase. Next slide, please. So, as our energy future changes around us, so must do the future of work. The way we work on site and how we collaborate as customers and contractors needs to shift to keep pace with technology, society, and competition. So, how to deliver this? Well, it always starts with a problem. Next slide, please. Welding is a critical path activity. Critical path activities are the tasks that determine the minimum time necessary to complete a project. Delays on the critical path affect the entire scheduling of a project, which almost always results in an increased cost to construct, either for the customer or the contractor, but ultimately feeding into the cost of our energy at home and at work. Collecting, collating, interpreting, and improving welding data is currently a really and very manual process, which is prone to error due to its complexity. This makes welding a time-consuming and resource-hungry task. So this project seeks to reduce the complexity, the time, and number of resources required by leveraging novel digital technologies to create a site ecosystem called Digital Inspector. Next slide, please. So, on to our findings. Next slide, please. Digital Inspector will be a complete ecosystem for monitoring and managing welding across multiple different locations simultaneously by connecting back office functions such as procedure approval and welder approval databases to site tasks with real-time weld data acquisition. The project is designed to be scalable and serve as an innovation platform for further site digitization, such as non-destructive testing, digital data, and connect to other software as a system services, such as Building Information Management, or BIM software, as it's commonly known. The successful delivery of the overall project concept will improve energy system resilience and robustness through improved quality. So things such as early identification of fabrication issues and non-conformances. But it will also improve construction transparency, such as the requirements for rework and lower costs through reduced downtime. Next slide, please. The contractor, United Living Infrastructure Services, which is who I represent, and our customer, Cadent, have identified the needs of the system in the orange box on the left. As we've progressed through the discovery phase, we have refined these needs into macro actions on the right, but the project refers back to sort of, to remain focused. The first 4 points refer to reductions in construction costs, production costs, project delays, and embedded carbon, with the next 4 points referring to transparency, such as the visibility of construction and real-time monitoring, and really the future-proofing of the investment through scalability and quality. So we've refined these on the right, and they've transformed into tangible outputs and, I suppose, guideposts. So, for example, by eliminating double and triple handling of data, reducing the amount of traveling needed by staff members, multiple user logins for both the customer and the contractor, an open-ended design ready to receive new modules and upgrades. Next slide, please. So the refinement of the user needs has led to several opportunities across 3 major pillars, and we've identified these as software, hardware, and accessibility. For example, the project needs software that must be sympathetic to site, as well as office operations. It's got to be scalable and agile and usable across multiple platforms, such as phones and tablets, but also readily linkable to other software via APIs. So this is a computer software that translates between one and the other. And currently, nothing of this scope exists on the market that could be identified by any of the parties involved. We also need new hardware so that the project does not lock the technology to a brand, removing obsolescence and further sunk costs. Yet it's got to be reliable and ready for upgrades later. And finally, accessibility. So transparency builds trust, and thus building a system that allows the customer to see and measure the same data as the contractor enhances relationships. Whilst the future workforce is considered to be tech savvy, the project partners recognize the current workforce is often technology shy. Therefore, users' interaction with the system must be simple and logical, requiring really minimal training. In the following slides, our project partners will deep dive into our work packages and provide proofs of concepts for some of the software and hardware options available to us. So, without further ado, I'd like to introduce James from Triton Electronics.
Thanks, Lewis. Hello, I'm James from Triton Electronics, and I'm going to take you through the outputs of the discovery phase on behalf of all the project partners. Next slide, please. Digital Inspector is going to modernise and digitise the way that welding projects are planned and welding on site is performed. There's a need for this innovation to bring together existing software and processes which work well independently but are fractured and inefficient into one system. This will streamline processes, allowing for time and cost savings, but also provide verification of data, prevention of errors, and lead to better use of data in the future. By providing an ecosystem for the digitisation of this data from start to finish, we are also starting the development of a platform which can be built and expanded upon in the future. There's scope for other projects, and as technology develops and our understanding of data improves, the potential for AI-driven planning and optimization tools, AI-driven defect analysis, and more. TWI already provide market-leading welding qualification and planning software packages, Welding Coordinator and Welding Qualifier. Triton have been developing monitoring hardware for over 25 years and have recently started providing some cloud-based data capture tools. In collaboration with United Living, Cadent, and National Gas, we've designed a platform which will seamlessly integrate TWI's software with a new dashboard service developed by Triton. The dashboard will provide project tracking, intelligence, and collaboration tools. We're developing an inspection app which will integrate seamlessly with the project and provide real-time data verification on site. The data will then be indexed and retained for long-term storage and analysis. We believe this platform will coherently address the user needs outlined. Next slide, please. This slide shows an example of how things are currently. As you can see on the left, important documents are filled in by hand. These will most likely be copied into an electronic format at a later stage, which increases the risk of error due to double entry and the human factor. On the right, you can see printouts from a monitoring device. These are glued onto paper and put in a file. The problems we're highlighting here are multiple data entry, large room for mistakes and errors, and no automatic data validation or verification. Next slide, please. A key output of the project, which has been led by TWI, is the conceptualization of what is a digital weld. There is currently no standard in place, domestic or international, which aims to define the variables and data which make up a weld in the digital space. This output will help standardize the definition of a weld, while also facilitating the communication between project components. We believe by completing this work, we'll provide an important output as a net gain, which can be shared internationally. TWI have started the process of defining a digital weld. The standard will have 3 levels: core variables, other process-specific variables, and procedure-specific variables. This standard will be worked on and developed as the project continues on, hopefully into alpha. Once data starts transferring between project partners, we'll gain a unique insight into what we believe need to be included, and also any areas of the Digital Inspector ecosystem that can be standardized. We're keen for Digital Inspector to provide a platform which is configurable, modular, and can be expanded upon easily in the future, with other third-party tools being able to integrate, and with users of the platform being able to transfer data in and out of the ecosystem with ease. Standardization will maximize the benefits Digital Inspector can provide to pipeline welding and other industries. Next slide, please. As part of the Digital Inspector project, we want to provide a new, innovative, low-cost monitor. The monitor will work with any welding plant, be completely unobtrusive and interchangeable, so it can be used on a rented plant, and if one breaks down, quickly swap with another to minimize delay in welding. This new monitor is key to addressing the identified user needs while also being a good opportunity in itself. We're developing an inspection app which will act as the control interface for the new monitor, but also as a digital record keeping tool for inspectors when they're on site. they'll be able to view all relevant data about the weld they are monitoring, such as the WPS and any drawings. And real-time verification will mean that costly errors, which can go unnoticed for weeks, are a thing of the past, because inspectors can be sure that the materials, consumables, and welders are valid as per the specification for that weld. Fab reports are completed at the same time as the weld, instead of days or weeks after the fact. This report then updates the bar chart, which is the live document maintained by inspectors as various welds are completed. This will provide an up-to-date tracking facility, which both main contractors and subcontractors are able to view and be sure that the jobs are proceeding as expected. If issues do arise, all parties are kept up to date, increasing visibility and trust. For Digital Inspector to function, it's very important that the monitors and inspection app have an internet connection. Pipeline welding sites tend to be in the limited areas of the country where there's no 5G or 4G connectivity. This is a problem which we needed to address in Discovery because it's critical to the functionality of the platform. We found a novel solution. The monitors will have a built-in ISM mesh network, which will enable connectivity across the entire site, so the monitors themselves can distribute a satellite internet connection. Next slide, please. The dashboard is the central hub of Digital Inspector when welding is taking place. We worked extensively with United Living engineers to gather requirements and gain an understanding of what the processes are currently and how they can be digitized effectively. The goal of Digital Inspector is to provide these tools not only to the organizations carrying out the work, which in this project is United Living, but also their customers who have a desire to also maintain an overview of what's happening at their sites at any time. And that would be Cadent and National Gas in this project. As part of the dashboard, we're building an API in collaboration with TWI. This will mean that the data can be seamlessly transferred from their project planning software at the point when a site is nearing going live. From a technical perspective, we spent a lot of time considering security and data protection processes to ensure that Digital Inspector is a safe suite of tools for use in sensitive environments. Once the data has been transferred to the dashboard and a pipeline site is live, the dashboard will provide a central location for all data being captured by multiple inspectors and monitors at that location. Collaborative tools will make responding to issues and events far easier, with quick responses meaning cost savings due to fewer delays. The monitoring app and the monitors will highlight any issues as they arise, whether it's due to welding parameters being out of range or the specification or incorrect material use for a particular joint. We will also verify welder qualifications with TWI's welding qualifier software. Digital Inspector will mean that if conditions for a weld are wrong, it will be flagged before going ahead. Currently, mistakes might not be flagged until the project's long continued on, meaning costly delays as the mistake is cut out and rectified. As part of Discovery, we went through a requirements gathering process with all the parties, resulting in our identification of user needs, reports of our findings, and some software concepts and mock-ups, which you can see on these slides. Next slide, please. With a desire for Digital Inspector to be a platform for future innovation and growth, we believe that under the umbrella of site intelligence systems, we can design the platform to be easily fed more data streams and expanded upon in the future. We believe this could take the platform in a number of directions and understand that with the rapid developments taking place, in AI tools in particular, it's important for us to design the platform in such a way that we're ready to exploit this. We wanted a method to display, in a high level and easy to understand way, all of the data we were capturing from the monitors and inspectors. As an example application of the use of the data, we believe having a visual history of every day that's taken place on site will be useful for quickly scrolling through the major events that have taken place. United Living, the contractor, or Cadent, National Gas, the customer, can drop in and see which inspectors are on site and where they are, but also which monitors are switched on and capturing data. This data will also be stored, so if the customer wished, they could fast forward through the last week on site, seeing a quick summary day by day of which welds were completed, where they were on the satellite map, by who, and who was inspecting. This data could then be piped off into a different system to be used for future optimizations, predictive models, or something else. Digital Inspector creates a unified platform for storing data so that in the future, we'll have a reservoir of data that can be interrogated for future planning and analysis. We believe that Digital Inspector can be itself a platform for innovation in the future of large construction projects and the drive to net zero. That's all for me. I'm going to hand back to Lewis.
Next slide, please. Thanks, James. Okay, so to conclude the presentation and summarize the project benefits, let's take a closer look at what each stakeholder can expect to receive, starting with the customers, such as Cadent. So for Cadent and National Gas and gas customers initially, but though this will scale into other sectors, the overall cost of constructing assets is reduced and streamlined by live tracking of costs, reduction of site personnel, and a lower likelihood of project delays due to welding. Critically, for this particular funding period, or the RIIO-2 funding, we expect that it will go further than originally predicted because of the net gains from this project, the streamlining and less rework, as we've discussed previously. And then there's further opportunities for site digitization, and these can be realized by using this project as an innovation platform for other digital bolt-ons. And we have a few ideas for that for other projects down the road, but its open-ended design is specifically so that you can attach other digital technology to it without necessarily adhering to the full ecosystem. The contractor, so there's a benefits for us as the contractor. Well, we'd be the front of industry innovation and high quality fabrication. We'll have improved productivity and reduced construction risk, which is probably the key one for us. And ultimately, that means we offer a significantly more competitive service. For our partners, TWI and Triton Electronics, they get to have new hardware and software, so within their existing markets, but that opens up new markets for them and their shareholders. And then finally, we have big data statistical control. So big data is one of those terms that's quite popular and I quite hate, but it is good in the correct format. And in here, the statistical control that we can draw from big data, and with further prediction models around AI, say like neural networks and foundation networks in AI, there's huge potential for being able to do all sorts of very practical things with digital data, as opposed to just data giving you a pie chart or a graph. And then the consumers, well, for the consumers overall, there's the increased productivity and traceability in the gas sector. There's the lower cost of a regulated asset, so this cheaper to build. So thereby providing an ultimate financial benefit to us as the end user or customer. The project improves the robustness and clarity of future energy systems, and future upgrades to the network cost less to implement. So the idea of this project is that we can bolt on into the future, looking at that 10, 20 years ahead when we are upgrading the network again, or we're finding that we need to finalize a few bits and pieces. The system isn't locked, and we're able to, push it forward and add stuff later dates. And that's it. And that's it from us. So next slide, please. Thank you. And sort of questions. Anyway.
Brilliant. Thank you so much, Lewis, and the rest of the team for a fantastic presentation. Really thorough. So we haven't got any Q&As in the box right now. So I'm going to kick off just because I have a gas operations background. So it's really interesting for me. So in terms of the technology itself, what actually is the technology? How does it monitor the welding points in the pipelines?
I'll hand over to James for that one because he's all over this. Understands more than I do.
So what our existing monitors do at the moment is they're monitoring various sort of factors which are taking place as welds are performed going around the pipelines. I guess what digital inspectors now going to do though is bring that. At the moment, inspectors will have these devices and they'll turn up and they'll leave and they'll fill in their reports and they'll do everything sort of off-site or after the fact. These devices literally print out, reels of paper with the parameters that they've monitored as these welders are performing these welds, which can take 4 hours. And then really it's up to the inspectors then and the teams in the office to, go back over and verify that everything was okay. And that also that everything would, all of the materials and everything that were going into that well, so 2 bits of pipe coming together and that kind of thing, were all valid. So really what Digital Inspector is bringing is all of that pre-planning material is then integrated within a system. The inspectors on site are no longer sort of offline, making notes on a piece of paper and, using printouts and that kind of thing. It's all recorded digitally and then it's verified because the integration with TWI's planning software means that we know that when these weld joints were planned, months ago, and they were tested as well. So when you build a specification, you actually perform tests to make sure that the materials can go together and that kind of thing. All of that data is immediately accessible, so that when things go together, welds are performed, we can be performing tests on the specifications that were specified months ago and just checking that everything is legit, basically. What has happened and what can happen is sometimes materials on site are wrong, or sometimes there's unexpected pipe, that kind of thing. And mistakes do happen, can happen, and those mistakes in the context of a pipeline site, if they're not identified immediately, can run into hundreds of thousands to rectify. So really bringing everything together in a manner that it can all be verified in real time, with the collaborative tools we've sort of been explaining and that kind of thing. That's what Digital Inspector's about, and that's what we're trying to do.
Brilliant. Thanks, James. We have 2 questions in the chat. The first one I think we've sort of covered, so I'm going to jump into the next one to save time. Could this solution help improve the insurance process in terms of risks and claims by providing better information on the network assets?
So I'm going to hand that one back to Lewis, because Lewis knows more about that, coming from that sector. But I think
yes, so we've taken the approach of this in terms of risk mitigation, but also risk allocation. So quite sort of the same sort of thing. You're looking at risk, but they are different streams. And yes, because it's data validation in the moment and real time, and then correction happens in real time too. It enables us as contractors. So as I'm physically building the pipeline, I'm able to correct an error immediately in the day. Now, it sounds like an obvious thing, but it doesn't happen at the moment because a lot of your records are delayed, or you may pick up something down the road. You can't have an expert that the insurance companies would like to have at every single point for every single service, for every single event that takes place. Instead, what traditionally happens in pretty much every company is that you'll have a base that supports front site. So site have their own experts, but not everybody's an expert. And then you have the back office. And this will reduce risk across both front office and back office systems. And it was crucial that we had that piece in, so that we could have a lower end of insurance and a lower end of risk overall, but then be more fiercely competitive, I suppose you could say, because the actual costs of construction are easier to identify. And so thus, the risk of something going wrong in the cost of construction are also able to be quantified much easier. So yeah, I hope that answered the question.